Good morning, all. Shall I start, Vishal? Am I audible?
Yes, ma'am.
Okay. So now, yesterday we started bilinear transformation, and we have seen the complete derivation, how to map analog this analog plane to digital plane for bilinear transformation, and the transformation which we have got is S is equal to 2 by T 1 minus Z inverse upon 1 plus Z inverse. Same thing can be written as 2 by T Z minus 1 upon Z plus 1. Now we want to determine the relationship between analog frequency and digital frequency, because everywhere in this type of filter what we are doing, yes, we are converting what we convert, yes, we are converting analog filter to digital filter. Is this okay? Is this okay? So now we need to convert analog frequencies to digital frequencies. So how do we write analog frequency? Analog frequency is written as this capital omega. What about digital frequency? Digital frequency is written as W, right? And we know that this Laplace variable S is equal to sigma plus j omega. And the Z variable which is used in Z transform is a complex quantity. It is R into e to the power j omega. Is this okay? These are the basic aspects. What is S? S is a Laplace variable we are using. Sigma plus j omega. Sigma is attenuation, omega is a frequency, analog frequency. Z is denoted by R into e to the power j omega in the polar form. Is this okay? R is the magnitude, omega is the angle. So now you can write down S is equal to 2 by T. In place of Z, I can write R into e to the power j omega minus 1, R into e to the power j omega plus 1. I hope everyone should note down. All should note down. Now, you can use the trigonometrical identities. E to the power j omega is equal to cos omega minus j sin theta minus j omega, like that, and then you can derive this, you can simplify it. You will get like this: omega equal to 2 by T 2r sin omega upon 1 plus r square plus 2r cos omega, and sigma equal to, how we have done this, S is equal to sigma plus j omega. Then you can equate real and imaginary parts, right? This also you can expand by using the trigonometrical identities, and you will get sigma equal to 2 by T r square minus 1 divided by 1 plus r square divided by 1 plus r square plus 2r cos omega. This is by simply using trigonometrical identities and equating real and imaginary parts on both the sides. Now from this equation, if r equal to 1, if r is less than 1, what will happen to sigma? Yes. Yes. If r is less than 1, sigma will be negative, right? If r greater than 1, sigma will be positive. If r equal to 1, sigma will be 0. Is this okay? Now, what is sigma? It is the left side of the S plane. What is r? Is the radius of circle in the Z plane. So now omega equal to, what is the significance of this? Can you write significance in the chat box? What is the significance? Yes. This means that sigma less than 0 is mapped into r less than 1. Means left half of the S plane is mapped into the region of radius less than 1 circle. What is this called? What is the condition of this? Yes, this is the condition of stability of the filter. In the previous class we have seen, right? So with this we can confirm that if the filter is a stable filter, analog filter, digital filter will also be a stable filter, right? And if r equal to 1, sigma equal to 0, means entire j omega axis is mapped into on the radius r equal to 1. Yesterday I showed you. Now for r equal to 1, we can write as r omega equal to 2 by t sine omega divided by 1 plus cos omega. Simply substituting r equal to 1, you will get this equation. Further, you can simplify this. This is the final relationship. Capital omega equal to 2 by t tan of w by 2. This is the relationship between analog frequency omega to digital frequency w in the bilinear transformation. Or in other way, you can write down omega equal to 2 tan inverse of omega t by 2. Now, what is the range of omega, which is a analog signal frequency? What is the range of omega, which is minus infinity to infinity, analog frequency? If you convert, we know that for digital frequency, the range is minus pi to pi. Means entire minus infinity to infinity is mapped to minus pi to pi. Now see here, if you use this equation, W equal to 2 tan inverse omega t by 2, and you can plot omega on x-axis and corresponding values of W on y-axis, you will get this type of curve. This shows mapping of analog frequency to digital frequency. This is 0 to pi, right? Now, see here what has happened. In the lower region, this is expanded, mapping is expanded. While in the higher frequency range, this much frequency till infinity, it is mapped in the only omega t to pi. That means it is compressed. So high frequencies are compressed, while the low frequencies are expanded. The graph itself shows. Are you getting this? This is called as frequency warping effect in case of bilinear transformation. And this is because mapping is non-linear. If it is linear like this, then no issues. Then this would not have happened. But now, since from the conversion of analog frequency to digital frequency, we have derived this equation. W equal to 2 tan inverse omega t by 2. And if you plot this same function, we can see that this type of, yes, curve which is a non-linear, and you see the mapping W2 to pi. Entire this region is mapped, means this region is compressed only into W2 to pi, while this region is expanded because see the curve. So now the conclusion is mapping, frequency mapping is non-linear. Lower frequencies in analog domain are expanded in digital domain, while high frequencies are compressed due to non-linearity function tan inverse, which is called as frequency warping. Have you understood? Write down in the chat box, then I will proceed. Have you understood what is the frequency warping effect in bilinear transformation? Yes. Is the clear? Is the concept clear? Write down, use the chat box. Same I am keeping as a record for your attendance. Keep in mind. If you are not responding in the chat box, means you will be marked as absent. Have you understood the concept? Okay. Now, take down next example. Take down next example. Convert analog filter with system function h of s equal to s plus 0.1 divided by s plus 0.1 its square plus 9. Yes, all of you should take note down and solve the example. What is given? What is given in this example? You are given h of s, which is the transfer function of the analog filter. Whenever s is there, means in the Laplace domain, and Laplace domain works in analog system, in continuous time systems. Parallel to s, what is in the discrete time system is z. Z transform we are using. Laplace transform is used in continuous time systems, while Z transform is used in discrete time systems, right? So now example is convert analog filter with system function h of s into digital IIR filter using bilinear transformation. The digital frequency, the digital filter should have resonant frequency or cutoff frequency WR equal to pi by 4. This is the problem given to you. Now, let us see the solution for the problem. H of S equal to, this is the standard formula, general formula for S analog filter. General formula, right? H of S equal to S plus A square plus omega C square. If this is the second order function h of s, then omega c is the cutoff frequency. These are all the standard notations and standard functions. For second order, first order is different, right? So you should know this. Now, what is omega c from this equation? If we use this generalized h of s, omega c equal to 3 radian. See, this is 9. 3 square is 9. So you get 3 radian per sample. right? Oh, sorry, this is the analog frequency. So 3 hertz, right? Now, what is done after this? Omega c equal to, you can convert this to, yes, write down omega c equal to, we know that 2 by t tan of WR by 2. So you can find out t, that is the sampling interval, which is not given. So 2 by omega c tan of this pi by 4 divided by 2, that is pi by 8. 2 of 2 divided by omega c is equal to 0.276 seconds. Is this okay? So this is how we can determine sampling interval. Why it is required? Why we derived this sampling interval? Because we know that for converting analog filter to digital filter by using bilinear transformation, simply we have to replace S by 2 by T Z minus 1 divided by Z plus 1, or 1 minus Z inverse divided by 1 plus Z inverse. Is this okay? Is this okay, Devashri Das?
Yes, ma'am.
So I hope everyone is understanding, because and parallelly you must write down on the notebook. Now, so for replacing Z by S equal to 2 by T, we need T. That's why we computed T. First, in the example, what is given, that you should write. Then you write down the formula, you know, right? Then you can see that what is required. T, capital T is required. So T is determined in this way. Now put T equal to like this, then your task is over. 2 by T Z minus 1 divided by Z plus 1, 0.1 its square, S plus A, that is Z plus A, S plus A, right? S is replaced by 2 by T Z minus 1 divided by Z plus 1 divided by, what was there? S plus A its square plus 9, or A square, right? So now this is omega c square. Simply put the value of T equal to 0.276, and you can calculate h of z. This is how you have converted h of s to h of z. Is everything clear? You write down and verify the answer. If you have doubt, you can ask me. Simply, again I am telling, for converting h of s to h of z, simply replace s by 2 by t z minus 1 divided by z plus 1. That's all. Now for replacing this, we don't know here capital T. So we need to find out capital T, whatever is the data given to you. So with this relationship, we know between the analog frequency and digital frequency is given. We could determine capital T. And this analog frequency also we can find out from this whatever is the system function given in the standard formula. Is everything clear? Devashri Das.
Yes, ma'am.
Aparna Konda. Aparna.
Yes, ma'am. Yes, ma'am.
So now, those who are attentive, see, it will help you. Those who are not attentive, it is very, nowadays, the examination pattern has been changed. It is not at all, it is not descriptive that you will refer 2-3 papers and you will get to. Conceptually, you should be very clear. Now, take another example. Now, solve yourself. I'll give you 15 minutes. Solve yourself. I have already solved, but you have to verify the answer. Is it done? Yes. Is it done? Shall I proceed? Aparna?
I'm solving it.
Okay, okay, okay. You write in the chat box one solved.
Yes, ma'am.
Verify the answer. Now, let us solve last example from this bilinear. Next time we'll see impulse invariant transformation, another transformation, right? So now, take down another example, a digital filter with 3 dB bandwidth of 0.25 pi radian is designed from analog filter. H of S equal to omega C divided by S plus omega C. Use bilinear transformation. What is given? A digital filter. Now instead of, they have not written the cutoff frequency of the digital filter. They have written 0.25 pi bandwidth, right? Is designed from the analog filter. See, it is very essential that you should understand what is given. Whether it is a, yes, you are given analog frequency or you are given digital frequency. Three different types of examples I have given to you. Here, clear cut digital filter with frequency, this one means this is small w. Are you getting? This is not capital omega. This is small omega, which is given, right? Because it is mentioned digital filter. Otherwise, somebody may take omega C. This is wrong. Is everything clear? Devashri Das, Kajal Jadhav. Yes. 3 different types of examples we are solving. In one of the examples, they gave you omega C like this. Some number was there here and S plus this number. So from that, we have converted that to omega R, WR. But here, digital filter with 0.25 pi radian is W is given. So now use the conversion formula. As we know, capital omega C equal to 2 by T tan of WR by 2, or the small WC also you can write down. So, and it is given 0.25 pi divided by 2, 2 by T, and T is mentioned? No, T is not mentioned, I think. Okay, let us see. So you can, if it is not mentioned, you can keep capital T as it is, or you can write down T is considered as one sample, 1 second. It doesn't matter if it is not mentioned, you can do it. So now omega C equal to 2 by T tan of 0.25 pi by 2. And you will get this. This okay. Now keep this value of omega C in H of Z. You will get this will be H of S. Sorry, it should be H of S. Omega C, why H of Z? Directly omega C is written. So instead of omega C, now you will be replacing this. Value of omega C, you have got this. And S is replaced by 2 by T, Z minus 1 divided by Z plus 1 plus omega C. Simply H of Z is replacing S by 2 by T, omega Z plus 1, Z minus 1, like this. So now final answer is like this. So you verify this answer. Solve this example, verify the answer. If you have any doubt, please ask me. Conversion of H of S to H of Z is h of z at, yes, h of z, this formula you can use. H of z equal to h of s at s equal to 2 by t, z minus 1 divided by z plus 1. That's all. Hmm. Solve this last example. Three different types of examples we solved. Devashri, Devashri Das.
Yes, ma'am.
See what is asked: relationship between or the conversion formula from analog frequency to digital frequency. Analog frequency is denoted by capital omega. Digital frequency is denoted by small w. Whatever answer you have written, no, this is for transfer function.
Yes, ma'am.
Ha. So why I am taking this practice for MCQ. Of course, this is required for descriptive questions also. So you should listen properly. This is the relationship I am asking between capital omega and W in case of bilinear transformation. So everyone, Neha, 2 by T tan of W by okay. Capital omega is equal to 2 by T tan of W by what she has written?
WT by 2 it should be, no?
WT. Where it is WT? You see the my files, all the files. Check. Just now today, what I have explained. See, capital omega equal to 2 by T tan of W by 2. If it is omega C, then you can write down WC. If it is omega, then only you can use it. Otherwise, you simply remember capital omega equal to 2 by T tan of W by 2. Is everyone clear? Is everybody clear? So write down all of you. MCQ practice this is. All of you should write down the relationship and you can exit. And capital W, Malekar, Vinita, Vinkita or what. So capital W is not the, you should not write capital W, it should be small w. Capital omega equal to 2 by T tan of small w by 2. WR is resonant, okay. So WC or WR, that is okay because this is a resonant frequency, but in general I am asking you the relationship. So don't write anything small w by 2, correct? So this type of questions are asked in MCQ. Or you will be given a frequency and write down the digital frequency using bilinear transformation. Then you should be able to do it. Once it is done, you can exit.